Gents, how are we going to tackle the first part of example 4? The current in each line. You definitely need to work out I phase, yeah. How are you going to do that then? Sorry? Well, have you? What you got to be careful of here? It's impedance. We got these are both in ohms, but that's an XL and that's an R. Yeah. So it's complex. So we got something like for each. If we isolate, we're looking for the current in a line. Current in the line and current in each one is the same because they're star connected. Therefore, we can isolate just one of these, can't we? And work on that, knowing that we've got a line voltage, we could easily find the phase voltage when we want to. Yep. Three is the real part, Alan. R's the real part. So looking at that load, we've got a triangle that is 3 ohms, 4 for XL, 3 ohms for R. This is the impedance Z. Yep. We're only interested in the magnitude here. We aren't worried about the angle of the current and the phase difference from the voltage at this particular moment in time. We don't have to worry about that. Yeah? So, we can say Z for each phase, we're talking about the phase impedance now, just isolated one phase, must be the square root of R squared plus XL squared, must it not? That's root of 3 squared plus 4 squared, and everybody ought to know the answer to that. 5 ohms. Very carefully picked by me, wasn't it? Alright, therefore, I phase is equal to E phase over Z phase. How can we rewrite E phase? We haven't been given it, but we have been given something else. In the problem, we've not got the phase voltage, we've got the line voltage. So higher phase voltage and line, how can we rewrite EP in terms of EL over root 3, yeah? Over our Z phase, that is 440. Yeah. No, we don't know IL. Not been given that. No, that's what you're trying to calculate, Matt, yeah?
Sorry, I was talking.
But IL and I phase are equal to each other, yeah? Over 5 equals. We get 50.8 amps. Yeah. So each phase current in that system, 50.8 amps. Part B, the total reactive power. Reactive power, so we're looking to find QT. We know I phase equals 50.8 amps, and we know XL is equal to 4 ohms. Can I ask you a question now? What are the 3 ways of calculating power? Write them over here. P is VI, P is V squared over R, P is I squared times R. Yep. So we could, if we're only talking about a reactive part, we could replace that for Q, could we not? Yep. So, can we not go Q phase is equal to I phase squared times XL, the impedance of the reactive component. That is 50.8 squared times 4. And I made that 10,323 var. Yep. And that's for one of the phases, but we want the total. So QT must equal 3 times QP equals 3 times 10,323 is 3968 var. So next bit is find the total power, was it? Yep, do the same method just for resistances. Okay, so I mean we got P phase is IP squared times R. Yep. P, I'm going to do it that way this time. P total is equal to 3 IP. Therefore, that's equal to 3 IP squared R equals 3 times 50.8 squared times 3 equals 3 times PP equals 3 times that, all in one go. 23226 watts. I made it. What we're going to draw to find the total apparent power. Yep. There's our old friend, the triangle. 23226. What was this? 30969 ST. And I made it 31921 VA. No? Hang on, where's I got that? No, Alan, you're right. I put the wrong, I put, that's in my notes down here. Give me the right answer, please. Sounds more like it. 38, what? What I've done in my rough notes of the problems is I've written the answer to, I've written the 7,742, the power for one phase and not the power for 3 phases. Everyone agree with that? Yeah? Last but not least, excuse me, power factor. Power factor equals PT over ST. So that we're talking about the power factor is the cosine of this angle. So that's this total power divided by that. That is the 33226 over 30969 equals. And my answer won't be right because I didn't. And that has to be a ratio which unitless because these are two things are essentially the same units. They're both volt amps. Yep. Power is volt amps as well. We just give it a special name, watts.